Hey there, everybody. I was asked to do a stream today that just kind of goes over all the pieces, at least that we're covering, of graphing rational functions. A couple of things that we are not going to tackle. All of our functions are going to have exactly one vertical asymptote. We aren't going to do any that have two. So if you're looking for that, I'll try and get that on another video if someone wants it. I'm also not going to go into anything other than horizontal asymptotes. Okay, if it turns out to be a slant asymptote or something else, I'm not going to actually graph it. Okay, there is going to be one example where we will have no horizontal asymptote, but that's just where we're going to leave it, and we'll put what we can on the coordinate plane. I might just go ahead and show you the horizontal asymptote just so you can see what the graph looks like. But other than that, I'm not really going to go into slant asymptotes. If you do want to hear about those, then let me know, and I can go into how to find slant asymptotes as well. Okay. And I'll get going on this in just a second. I am starting with something that's already factored, so we don't have to worry about that piece. If that is an area that you're struggling with, at least for this first question, we'll have that out of the way. Good to see some people here today. Thank you, thank you. Hello, hello. How you doing, Jada? So hopefully this covers what you were asking about. Well, let's go ahead and get started then. Good. Bit frustrating over here on this end. I've been trying to update grades all morning. Ended up starting this stream just a little bit late because Power School is being a jerk today. Actually, I'm looking over at the computer and it's still trying to load the update I did on some grades. Very frustrating. All right, here we go. Excluded values, okay? Just as a quick little recap, excluded values is going to be whatever would cause the denominator, the bottom, to equal 0, all right? And the setup for that, you would basically do like x plus 1 equals 0, subtract 1 from both sides, and you get -1 as the excluded value. Excuse me, that comes from that one. And then this one here gives us -3 as its excluded value. Okay. Now we can go ahead and do some canceling. All right, there's an x plus 3 up here and an x plus 3 down here. The one that does not cancel is your vertical asymptote, okay? So the -1 is the one that did not cancel. So x equals -1 is the vertical asymptote. The whole, which is called a removable discontinuity, is the one that is canceled out. So that's going to be an x that equals -3. Right? All right, good times. X-intercepts, you might remember, that's what causes the top to be 0. Okay, when this is simplified, we end up with x minus 2 over x plus 1. What we care about is whatever would cause that to be 0. Okay, so you can set it up as x minus 2 equals 0. Add 2 to both sides, and you do end up with x equals 2. All right, so our x-intercept is 2. Okay, the y-intercept is whatever you're going to get when you plug in 0. Okay, so I'm going to take this one here, the simplified one, and say 0 minus 2 over, 0 plus 1, and that would be negative 2 over 1. In other words, negative 2 is our y-intercept. Okay. Degree of the top and the bottom. All right, these next three are going to be all the pieces for finding a horizontal asymptote. The degree of the top, if we were to multiply this out, you've got an x times an x. That's going to be x squared, or a degree of 2. The bottom, same deal. X times x, that's going to become x squared. It's also a degree of 2. All right. So the degree relationship, we can say that the top is the same as the bottom. They are the same as each other. And the rule goes that you're going to use the leading coefficient over the leading coefficient. So right here, in its simplified form, you can say that there is a 1 sitting in front of both of those. Okay. The other way to go is if you were multiplying this whole thing out, x times x, that would give you a 1x squared at the beginning, and the same thing happens for the bottom. The point is that our horizontal asymptote is going to be y equals 1. Okay. And then the last bullet I have there is test points, and I put a little question mark next to it. If we need to do test points, we can do them. But let's go ahead and start putting on the graph what we know. We know we have a vertical asymptote at negative 1. Okay. We know there's a horizontal asymptote. I'm going to jump down here at y equals 1. Let's see, x-intercept is 2. We'll put a dot right there. Y-intercept is negative 2. We'll put a dot right there. And now let's take a look at the whole. For the whole, I want to go to the reduced expression here. So we're going to do negative 3 minus 2 over negative 3 plus 1. Okay, that's going to be negative 5 over negative 2. Or in other words, positive 5 halves. Negative divided by negative. All right, so here's negative 3. 5 halves, that's basically going to be the same thing as 2.5. So we'll just go over here to 1, 2.5. That'll put it right about there. Okay, and we've got an open circle in that spot. If you want to do a test point, you can, but I think we got plenty to know where our L's are going to end up. We'll do one of them here. Boy, that looks terrible. There we go. There we go. And then the other one's going to go pretty much the same way. It's going to be over here. So we'll go like that. All right. Oh, that's what the problem was. 2.5 would be... No, that's the right place. Yeah. So basically, that is this one graphed. Let me back up a little bit so you can see most of the problem on the page. Why would the circle be open? Because that is a hole. literally, I mean, if you want to think of it as, rather than a circle, you can say, hey, it looks like a hole. But this is the place that you can't plug in -3, because in the original it would make this 0, and you can't divide by 0. But it would also make the top 0 as well. Okay, that's why it's not a vertical asymptote. It's just a hole. It's just that one little piece of the graph has just been taken out. Okay. Let's do another one. This one here is not already factored, so we are going to have to do a little bit of work for it. Right here we've got x squared minus 4. That is your difference of squares, meaning you've got x plus 2 times x minus 2. The bottom, looking for two numbers. When you multiply them, you get 2, and when you add them together, you get 3. I'm thinking that'll be 1 and 2. X plus 1, x plus 2. Okay. So this guy here, that's an excluded value of -1. This guy over here is going to be an excluded value of -2. Let's see about reducing this. If we reduce this here, the x plus 2's cancel, and you're left with x minus 2 over x plus 1. The one that was not canceled out is this guy here, -1. So x equals -1 is our vertical asymptote. And the whole is the one that was removed. So that's going to be x equals -2. If you want to go ahead and find out where that's going to be, you can. You're just going to take this that I put in red, -2 minus 2 over -2 plus 1. That ends up being -4 over -1, or just plain 4. So there is going to be a hole at -2, 4. All right. X-intercept, that's going to be whatever causes the top to be 0. That's this guy right here. And that's going to be 2. So the x-intercept is 2. The y-intercept is whatever you're going to get when you plug in 0. So you've got 0 minus 2 over 0 plus 1, -2. Why would the x plus 2 be crossed out? Well, because here you've got an x plus 2 on the top and an x plus 2 on the bottom. So they both, it's kind of similar if we had something like, I don't know, 3 times 5 over 7 times 3, and you would cancel out the 3's, but the 5 and the 7 would be left alone. So 15 over 21 would be that fraction originally, the one I'm just kind of made up, would reduce to 5 over 7. So same idea there. It's just what it looks like here. Simplifying rational expressions. Cool. Alrighty. The degrees, just look at the exponents here. The degree of the top is going to be 2. The degree of the bottom is 2. Okay. So the relationship, they are the same. Same on the top as it is on the bottom. When it's the same, it's the leading coefficient over the leading coefficient. And once again, like the last time, there is that 1 that's understood to be here and a 1 that's understood to be there, you end up with y equals 1. And then the last thing it brings up again is test points. If we need to do that, we will, or if you want to do that, we can. But let's go ahead and get started with putting this stuff on paper. Well, virtual paper. Vertical asymptote at -1. So we'll put a little do here. Okay. I like to put my asymptotes down before I do anything else. That's a me thing, I guess. But we're going to go ahead and put horizontal asymptote here. This gives us a nice frame. So the pieces are either going to be here and here, or they're going to be here and here. All right, so it gives us already a nice little visual of what the graph could look like. Y-intercept at -2, right there. X-intercept at +2, there it is. And then we already said there's a hole at -2, 4. So we're going to put a hole right there. If you want to do some test points, you can, but I think that's plenty. We've got 3 dots. 2 of them... Oh, wait a sec. Did that just happen that way? Did I really give you guys a graph that does this? X-intercept is... Oh, haha. Yeah, that's good. Y-intercept is... Oh boy, I did give you one of these. Okay, this one is... What? Oh, now I've confused myself. Oh, I see what the problem was. Why did I make this negative? That should not have been. I was talking so much about it that I put it in the wrong spot. Yeah. So it's totally... Thank you for catching that for me. Oh, there we go. Now the dots make sense. Here the dots will give us a graph over here. And then on this bit, it'll give us up to that, and then down to there. Graph is nice and ugly looking. I mean, no, I meant to do that to see if you would notice that the horizontal asymptote was supposed to be 1 and not -1. Yeah, that's the ticket. It is Monday. Yesterday was a crazy day. It was Mother's Day and my daughter's birthday. Just all sorts of craziness in one day there. Alrighty. This one here, there's no factoring you can do. This is linear, x plus 4. This is 2x minus 1. There's nothing in common that you can like factor out or anything. So nothing's going to happen there. Down here, that gives us -4. That is the only excluded value we have. It was not removed, so it is a vertical asymptote. There is no hole for this graph. X-intercept, remember that's what you get, or that's what would cause the top to be 0. All right, that's 2x minus 1 equals 0. Add 1, and that gives you this. Divide by 2, and that gives you this. So the x-intercept is 1/2. The y-intercept, again, that's going to be what happens when you plug in 0. So we have this over this, which gives us -1/4. Okay. All right. They're both linear, so the degree of the top is 1. The degree of the bottom is also 1, which means they're the same over the same. When it is the same, top and bottom, we still use the leading coefficients. Okay, this time, leading coefficient here is 1, but here it is 2. So we're going to end up with y equals 2 over 1, or just 2. Okay. Let's go ahead and put this down. Maybe we'll do a test point this time. Maybe we won't. Let's see. -4 is our vertical asymptote. That is a positive 2, it looks like, I think, still. So we'll put that way up here. We have a y-intercept at -1/4. Since we're just kind of graphing, let's see, -1/2 would be about there, so -1/4, let's say it's about there. And I made the dots so huge that yeah, -1/4 is in there someplace. And the x-intercept is 1/2. There we go. All right. We've only got 2 dots to work with this time. If you want to really get a good vibe on what's going on, we probably do want to involve a test point, something that's on the left-hand side of our vertical asymptote, just to make sure we're doing it right. So let's see. I'm thinking -6. Why did I choose -6? I don't know. I just kind of felt like it. And that's x plus 4. If you wanted to choose -5 or -8 or heck, -4.5 you could have used, although that's kind of weird. Let's see. So up top we've got -13. And on the bottom we've got -2. In other words, that's 13 halves. Okay, that'll be 6.5. So here is 6. There's 6.5, right? Right about there or so. So yeah, it looks like it's doing what we wanted it to do. So I'll go ahead and put, boy, that looks terrible, some sort of an L-ish shape here, and some form of an L-ish shape there. We could be more specific with what those look like, but it's not something I'm asking for this Algebra 2 class. In another context, I might want to have a little bit more going on, but not in this case. All right, let's take a look at another one. What did I try to do here? Oh, yeah, okay. All right, this one here, it's another factoring bit. We've got x plus 3, x minus 3. The bottom, it's a binomial, but it's not a difference of squares. What we can do is factor out an x. So it gives us that guy right there. And this is the piece that's ever so slightly different from the last couple. So this one here, that just means 0 is an excluded value. And then this one here tells us that 3 is an excluded value. Okay. The 3 is the one that gets canceled out. The 0 does not. So the vertical asymptote is at x equals 0. Okay. and the whole is going to be where x equals 3. Alrighty. Our simplified version of this is going to be x plus 3 over x. To find the x-intercept, you're looking at whatever would cause the top to be 0. In that case, it's negative 3. Okay. For the y-intercept, remember, you're going to plug in 0, and that's going to be 0 plus 3 over, there's a 0 on the bottom. There is no y-intercept for this one. Correct. Well, positive and negative. They have to be the same sign. Like in this case here, they were both x minus 3s. They're both minus 3s. This one over here, nothing canceled out. This one up here, it was x plus 2s that canceled out. So plus 2, that's the same. And then here, x plus 3 was what canceled out. So I'm not sure what you meant with the whole positive and negative bit there. But yeah, the whatever piece is identical on the top and the bottom are what are going to get canceled out. Those are the pieces that are common factors. All right, so the degree of the top is 2. Degree of the bottom is 2. So they are both the same. Which means the horizontal asymptote is going to be y equals leading coefficient over leading coefficient, 1 over 1 equals 1. And let's put pen to paper. Vertical asymptote is right here. Kind of doing these at a little bit of an angle so we can still see them. Horizontal asymptote at 1. We have an x-intercept at 3. No, we do not. That's a negative 3. X-intercept at negative 3. Sorry, I was scanning weird. I was looking here. The whole is at 3. Okay? If you take 3 and plug it into the simplified version, you do get 6 over 3, which is 2. So we know that 3 comma 2 is a whole. Okay. I would say technically we do have enough information without needing to use a test point. We have one in the bottom left section of the graph and one in the top right section of the graph. So if we want, we can just go ahead and go through here, hit that hole, go around it. There we go. It's probably my best L yet today. And then we'll do the same thing this way. Actually, as far as the graphs go, this is probably the best one today. Maybe this is a change for the good. Okay. All right, let's keep going. I'm trying to give one of every type of scenario that I could think of that you'd have to be worried about. Okay, so this one here, there's nothing to factor. In fact, there's no x on the top at all. So the bottom here is negative 4 as an excluded value, and that is a vertical asymptote, which means there's no hole. None. Okay. The x-intercept is whatever would cause this guy here to become 0. This is never going to happen. So this one has no x-intercept. Y-intercept, though, we can work on. That's going to be 5 over 0 plus 4. In other words, 5/4, or that's 1 1/4. Or 1.25 if you want to think decimals for graphing purposes. All right, the degree of the top, since there's no x here at all, it's a constant. That means the top has a degree of 0. The bottom does have an x, and it's being raised to the first power, so that is 1. So the relationship is the top is smaller than the bottom. Okay? When the top has a smaller degree than the bottom does, the horizontal asymptote is always, always, always y equals 0. Okay? We might need to do some test points. Let's see what happens here. We've got a vertical asymptote at -4. Let me make this a little bit bigger. Oh yeah, that's much easier to see. The y-intercept, or sorry, the horizontal asymptote is y equals 0. So there it is there. Y-intercept is at 5/4. That's 1 1/4. It's kind of there-ish. Okay. And you know what? That's really all we have. There's no hole and there's no x-intercept. So I kind of want to go ahead and do a test point. Okay, so if we're going to use 5 over x plus 4, and it's got to be something that's way out this way. How about if we use -5? Okay, so you're going to do 5 over -5 plus 4. That'll be 5 over -1. In other words, -5. So the ordered pair -5, -5 is part of this graph. -5, -5. There we go. All right, so we'll put one bit of L there. Boy, that looks terrible. And we'll put another one kind of sort of here. That looks mildly less terrible. All right, let's just do one more. Here it is. The top is going to factor. That'll be x plus 5, x minus 5. Okay. All right. Excluded values. The only thing to exclude is going to be -5. Okay. The weird thing here, though, is that the x plus 5 is what cancels out. So what you end up with is this, just x minus 5, when it's simplified. Okay, vertical asymptote, crazy, there's none. And the whole is x equals -5. X-intercept, it's whatever would cause the top to be 0. In that case, it's 5. The y-intercept is what you'll get when you plug in 0. That'll be -5. The degree of the top is 2. The degree of the bottom is 1. So we have larger over smaller. I cannot spell the word smaller, apparently. Smaller. Okay, now this is where I said I wasn't really going to go into much detail. Okay, all we need to know right now is that there is no horizontal asymptote. If the degree of the top is bigger in any way, shape, or form than the bottom, then there is no horizontal asymptote. Okay, now I don't want to put this one on the page because it actually does end up being a little bit more complex than that. We're not studying other types of asymptotes. Some Algebra 2 classes elsewhere might be touching on slant asymptotes and the like. I'm not gonna spend any time on that. So we're not gonna graph this one. All right, I'm not gonna ask you about a graph for this one for my class. You'll just be looking at a situation where the top has a larger degree than the bottom does, which means there is no horizontal asymptote. Alrighty, and that's basically it. That's every scenario I could think of that you would need to be responsible for our Learning Target 11 on graphing rational functions. Any issues still, or things I can help with on this, or one of these problems you're just going, holy heck, what just happened there? All right, well, I'm not hearing anything. So looks like it's pretty good, and I will talk to you later.